Good afternoon, I'm on site here at Embedded World 2022 and joining me today is Sven and Lorandt from Würth Elektronik, so thank you both for joining me. And we're going to be talking about the exciting world of e-mobility today. So e-mobility horizons are widening, as we well know, so how many sectors does Würth address with its components?
Yeah, first of all, thanks very much for having us. Yes, regarding e-mobility, it's really a focus topic inside Würth Elektronik. As an electronics company, we must focus on this big market. Yeah. And we have divided it into four major segments that we are trying to attract that our products shall be sold in. Yeah. It's light electric vehicles, so everything from the kick scooter, e-bike, maybe electric two-wheelers. Mm-hmm. Then everything that is regarded to electric cars, buses, trucks and so on, which is our second segment. Then all of these vehicles have to be charged somewhere. Yeah. So our third sector is the charging infrastructure at home with your wallbox or in public areas with AC or DC charging stations. Mm-hmm. And at the fourth segment, we put in everything that is not related to the first three ones, so maybe electric boats, drones, which is a very interesting topic, electric robots and so on.
Sounds like a very exciting space to be working in. So what sort of trends are you seeing in e-mobility at the minute and how are you seeing the future?
Yeah, so we're seeing, as many other competitors or also our customers, see four major trends. The first one is the electrification trend. So everything in mobility is being electrified and powered by a battery or by a fuel cell. So both technologies come up very much and always a power electric drive system. Then we see the connected trend. So you as a driver get connected to your car gets connected to the outer world, for example to the traffic lights or to other systems. And for sure the car communicates with you as a driver again. So there is a big trend to this connection. Mm-hmm. The third one is everything related to autonomous or automated driving. So we will not be, I hope that my little children will not have to do a driver's license, but that the car drives them to everywhere they want to go automatically. Yeah. And the fourth trend is the shared trend. So today we own our cars, or the majority of people owns their cars, but we think that in the future it will go, the privately owned cars will go down and people share the mobility. So they order a car when they need it, and then once they have finished the ride, the car picks up another passenger. This is the future, and this will be the future in our point of view.
Yeah, that sounds excellent. So going into more detail, how do you help designers ensure EMC suppression is in place for e-mobility applications? Sort of tell us about the components that you supply.
I think this question I would answer it because I'm field application engineer for Automotive. I think that it's very important that the designers who are designing this kind of automotive cars autonomously driving and all this safety is very important in EMC because you can imagine if you drive a car autonomously and you have a perturbance from a mobile phone or from imported Wi-Fi station and car start to make a full braking or something, EMI, it's a very important point. So you have to use components which is shielded, like all our inductor, we try to make them and design them to be completely shielded and to be immune for the external electromagnetic fields. Yeah. This is very important, and many designers, they take in consideration that. A designer who doesn't do it will have to pay back when he goes to the qualification and lab. Yeah. And then they have to redesign. Yeah. So this is also a big lack of time and money, of course, because you have to think on EMI on beginning on. Before you make your PCB, you have to put the right component in the right position and to think not only just to fulfill the law. Only just the EMI law is not a guarantee that the car will really have no malfunction or no perturbance to other cars, because car-to-car communication, car-to-other traffic light or something, if you have the wrong information because of some EMI issues, because the sensor did not recognize correctly, I don't want to have that car. No. I prefer to drive myself in this case.
Yeah, that sounds like a really important point. And as you say, safety is crucial. So what standards need to be met for both electric vehicles and their chargers?
Yeah. So talking about maybe only the standards for electronic devices.
Yeah.
There are three major standards that we have to obey. The first one is it's not a standard, it's the qualification called AEC-Q qualification. In the case of passive parts, it's the AEC-Q 200. So it's a certain qualification process that we have to fulfill, or that we have to fulfill and guarantee to our customers. The second one is regarding the processes and the production facility. It has to be certified according to IATF 16949, which guarantees to our tier 1 or tier 2 customers that our electronic parts are produced in a safe way. And the third one maybe is the PPAP level declaration, that we guarantee to our customers a constant quality based on their design-in samples. So these are maybe the three major ones for automotive, the automotive world. Yeah.
So following on from that, Wurth has several inductors for high power applications. So where is it being used in e-mobility?
Well, high power, it's always the matter what kind of power it is. It is power in terms of lot of amps or high voltage. It's power you can handle in different ways. So I have here some samples from us, like this is an inductor in this size. We can handle up to 60 amps. And this is a very small in comparison if you think 60 amps which can drive through this component. Instead of using round wire, use flat wire to have low DC resistance, to have low self-heating, but also very important, the reliability. So it must withstand all this vibration and all this test. And AEC-Q 200, like my colleague told before, this is a minimum request. So we try to qualify our product even higher and more rush environment, like the AEC-Q 200 just request, because we want to be safe and we want to keep our name clean, that our product will not fail in the field. So like we make 5-time reflow process testing because AEC-Q doesn't request at all, but we make that just to be sure that this component, if it's handled in his parameter, it will operate in the right way. Other side, if the customer doesn't need the 60 amp high current, you can downscale also to the 30 amp. It's a 30 amp completely shielded, EMI perfect shielded inductor, so he himself, he will not generate any electromagnetic field to outside, and of course, because it's completely encapsulated in a magnetic case, it will not be affected from external environment. And the most high-tech product that we have, it's a very tiny one. I think in the camera even you will not see it. It's like a small bug, completely packaged. I will give it to you to remember Würth Elektronik.
Thank you.
This is really
I'll try not to lose it.
Next time when we met, I want to see if you still have it.
I'll keep it in my purse, nice and safe.
This is something really the highest density what you can reach in terms of a passive component. So we make a wire like an air choke, and then we put iron powder mixture and we press them together completely. So it's again completely in magnetic field closed and has the highest current with the lowest DC resistance and the lowest package possible. Of course, he will never handle 60 amp because you don't have the soldering pad for that. But it's amazing how such small component can go up to 10 amp. So this is something which Würth Elektronik did develop for more like 5 years long, and now it's automotive product standard, and you will see many applications with component because the customer, when they see this and then say, oh, you have this as well, they say, oh, we can downscale everything. So
fantastic option for designers.
It's a good option,
So e-mobility components will be in demanding environments, as we've sort of covered. So how are you ensuring their robustness?
Lorandt just gave the hint a little bit. So there's the AEC-Q qualification, which covers, let's say, the basic demands. But as he said, it might be not enough for all applications in automotive. So for example, if we think of the shared mobility, the shared vehicle will be used much more frequently than the privately owned ones. So privately owned vehicle 1 hour per day, shared vehicle 10 hours and more per day. And this means that the mileages will be much higher, and therefore that the car does not fail after 3 years. The electronic components have to be much more robust. And this is the reason why we also put more stress in our qualification phase on these parts than the standard makes us to do. And so this makes us, and makes, we also see the demand from customers coming up, that they demand these higher qualified parts from us.
Of course, yeah.
And for the customer who failed the EMC test because they forget to put something on the board, we still have the snap-on ferrites, which is you can snap it on the wire after you finish the product, or if it's something which you can solve by harness, by wiring, you can put that between the different computers with data cables. So we have plenty different solutions what we offer the customer. Of course, this is the last solution, the best solution, use on board that one. And to be, of course, choose the right supplier to be safe that your component and your device in the future in the market will still operate.
Yeah, those ones sound very handy. Now, I believe you're also supplying components to several e-racing teams, which sounds quite exciting. Can you give us some more details on those?
Yes, so we have been active in this field for more than 10 years, I think. And our very famous partner Audi Sport, which was active in the Formula E and also won several racing series. They unfortunately they quitted the series, but we were a very close partner to them. So we provided them with technology, with electronic components, and so this was a very good relationship. And now, for sure, good that we have still nice partners. For example, in the Formula Student, it's also a racing championship. We have solar cars projects that we support, and there are several other racing teams. And this is not only fun for us, so for sure we like e-racing, it's nice, but it also has a professional background. So if you think of this part, just to give you an example, it handles high currents, which is very important, but it's also pretty big. So how does this part behave in rush conditions, in racing conditions? For example, with the vibrations. And in racing, we learn much about our products and with this we can improve our quality and even add some nice features to our products.
Yeah, that's interesting and such a great application as well. I love that story. So finally, how do you work with Digi-key to support your customers in the e-mobility market?
Yeah, so Würth Elektronik is, I think, famous for personal assistance. So this is the same that we do with Digi-key. So whenever a customer from Digikey has any special questions, we are there in behind. Okay. So we support Digikey's customers. And also, for example, in marketing topics, we work together to have nice campaigns together. And I think it's a very strong and fruitful relationship.
We made webinars together with Digi-key for the customer, which was invited from Digi-key and from Würth Elektronik together, which it was not a sales seminar, it was technical seminar, how to use the component in the right way. So Würth Elektronik and Digi-key have a very strong relation to each other. So
excellent. Well, thank you both very much.
The future is prepared.
Yeah, thank you both for your insights into the e-mobility market and for bringing your components along to showcase, even the really tiny one. So yeah, fantastic. And I hope you enjoy the rest of your show.
Thank you so much.
Thank you very much.